Hi, everybody. This is Mark Schaefer with iNEMI. Just wanted to let you know that you should be on mute, and I would ask that if you have questions during today's session that you please type them into the chat window. We'll be monitoring that. I will also try to ask those questions at the end and/or unmute you if the lines are not too noisy. But we'll be getting started here probably in the next 5 minutes or so. We're still waiting for all of our speakers and other attendees to join us. So please enjoy the relaxing silence. I don't have any hold music for you. We'll get started in a few minutes. The screen look all right to you, Dan?
It does.
Okay, as long as it's readable. And Dan, I hope you can play backup if Girish can't get in due to his connectivity and hurricane issues. Hi, everybody. This is Mark Schaefer with iNEMI. We'll be getting started here in just a minute. So Dan, I'm not seeing Girish here. I'm wondering if he lost connectivity. Are you okay if we begin? And if he joins us, I'll get him to speak. Otherwise, I'll have to ask you to do his slides.
Sure.
I don't know.
just sent him a text.
Okay. And neither can Julie, can't join either. All right, let me see what's going on. Let's see, maybe he's having the same problem Julie is. All right, let's try this. Let's see, sorry everybody. We're trying to fix two of our speakers from showing up. All right. Hopefully that will.
All right,
get
I just spoke to Girish. He said that he doesn't have the link.
I know, that's weird. He sent me an email as well. I just sent him the link. So sorry, everybody. We're working on our things. Julie's made it in. Let's
Hello,
see.
yes.
Hi, Julie.
I'll be watching the chat.
Okay, please do. Thank you very much. And I will send Girish an email. Yeah, I know. I know there's no other. That's fine. Send it to him anyway. All right. Let's give it one more minute to get our other speaker to join us, I hope. And I guess Dan and Julie, please check your calendars for the invitation for tonight. If you don't have that, I can try to fix that as well.
Well, I had it in my calendar. It just didn't want to
It just doesn't want to do it. It just doesn't want to connect. Yep. Teams. It sometimes, yeah. And there's Girish. Let's see. Make him a presenter. All righty. Girish, can you hear us now? You should have control of your mic. I see you've unmuted, but I can't hear you. Just technology.
Can you hear me now?
Yes, sir. We got you. There we are. Awesome.
Super.
All right. All right, everybody. Sorry for technical problems. It's all my fault. We will get started here right now. So thank you all. My name is Mark Schaefer. I am the project manager for iNEMI. This is the Tech Topic series on complex integrated systems. This is our first session. We're going to have this set up as hopefully around a monthly session for everybody to educate you on what's going on with complex integrated systems, as well as to get examples of what folks are doing, the things that are good, the things that are problems, and how they're overcoming some of these, and hopefully will lead to some calls to action that we'll talk a little bit about at the end of today's session as well. I want to let you all know you are on mute. If you do have questions during the session, I would ask you please type them into the chat window, and I will gather them and we will ask questions after everybody has presented. We also will be trying to monitor the chat, so if you do have a question we can answer in the chat, we will try to do that while the speakers are talking. Do want to remind you that the slides will be available after the session. We are recording this as well, so the recording either from this morning session or the evening session that we'll do that is the same as this. One of those recordings will be available, and we'll send that out to everybody that registered. So I want to thank you for your time and attention today, and sorry for the little bit of a delay to get started, but we are here now and I got everybody. So thank you so much again for your patience, but I'm going to turn it over to Dan, who is going to begin our journey in complex integrated systems. So Dan.
Okay, well, thank you very much, Mark. And I'm hoping that many of you already are well along your way on that journey. And if not, hopefully after today's morning session, you will join the journey and run down to your next bus stop. So basically, as you know, iNEMI and has several partners that it works with. And one of the important activities these partners is to conduct a situation awareness. And over the last few years, we have seen a shift in capabilities. We have seen ecosystem movement, and we've really tried to make sure that as an industry, as a community, that we are prepared to address and to intentionally be very thoughtful on where we should be investing our dollars. So with that said, earlier this year in March, we collaborated with IPC, that's iNEMI and IPC. We brought together several thought leaders that had been discussing some of these mega trends that have been appearing in the industry. We went through a rigorous process to assess whether it was an anomaly or whether it was truly a substantive megatrend. And that resulted in the white paper. We invite everybody to download that white paper. The white paper was meant to get all of our ideas and all of the observations we had been collecting over the last 3 years. And it was trying to propose a structure. And so on the left-hand side of the slide, you see that there's we tried to put in perspective levels. As you know, our industry, wherever you are in the electronics manufacturing ecosystem, everyone loves to use the word levels. And so we tried to propose a level system, starting with the wafer level 0, component level 1, module level 2, and system level 3. By the end of today's workshop, you will appreciate mostly the system level. We will talk about some of the other levels, but really the focus today is on the system and specifically what we are referring to in terms of complex integrated system. So I invite everybody to download that white paper. And also I really encourage you, if there is something that you feel has been captured incorrectly, let us know. If there's content that you think needs to be added, please, we're always open to updating the white paper. Next slide, please.
I also want to let everybody know I did put in the chat window the link to be able to download the white paper. So if you're looking for that, you can click on it.
Thank you, Mark.
Yep.
Appreciate it. So what you'll see in the white paper is a definition. The definition stresses the fact that it transcends different types of environments, whether it's the digital environment, the analog environment. We've seen a significant increase in optical interconnects, especially as people are challenged to be able to manage the amount of data required to do the AI analyses that people are proposing will revolutionize the way we conduct our business, live our lives, and basically just accelerate the innovation cycles concerning engineering. We also see that there are significant micromechanical, power-related, and structural. I think that in the end, what you'll notice is that there are many instances of examples that we already have that are considered complex integrated systems. And what we're trying to do is really propose a lexicon that helps us communicate more efficiently and make sure that we're not simply developing new taxonomy for the sake of building out acronyms. Next slide. As I mentioned, we historically as a community are doing significant amount of situation analyses and trends mapping. For those of you on the call, I'm sure that you're familiar with the different types of roadmaps that exist, whether it's the IEEE, the iNEMI, the SID, almost every single trade industry, automotive, aerospace, or other, they all are basically collecting information to help individuals make decisions, strategic decisions, which ultimately de-risk on the standpoint of technology, manufacturing, and investment. The most common and really the beginning for us in terms of how we looked at this white paper is that we've seen this drive in terms of designs, materials, and processes. Packaging, obviously, today is one of the largest on stage in terms of opportunities on how we can be more competitive. And then also just with the emergence and then growth and unbelievable predictions of growth for some of the industries. The ability to have much more smaller footprint, lighter weight, lower power, more operational resilience towards reliability, and then the ability to withstand harsh environments. All of those are really driving. And so with packaging as kind of the background and the one trend that we've been observing, we started noticing another trend. And so next slide. And the next slide shows kind of what we observed. The trend was, and we tried to keep it simple. It was semiconductor assembly, packaging, and test. But if you look down into semiconductor assembly, packaging, and test, what you'll notice is that in these capabilities that historically had been within one vertical, that being either in the middle end of line or back end of line of a foundry or at a OSAT, what you notice is that today there's a greater demand and a premium placed on the ability of having one location, one facility, one clean room environment that has the ability to place very novel pieces of hardware, different components, have the ability to dispense functional inks, being able to meter them down to microliters and milliliters, and then also be able to conduct in situ testing. And so if we look basically kind of as a list of potential components and other types of materials that you would see in a facility that operates and is building complex integrated systems, what you notice is that they'll have a ability to place CMOS chips. They'll be able to place lenses. They'll be able to place high precision mirrors. You'll also see them have the ability to handle wafers, handle individual die. They may be a photonic IC. They may be laser diodes. They may be able to, or light emitting diodes, excuse me. You may be able to have fibers. So you begin seeing the variety of different components. We still will have traditional electronics. You still will see ICs. You still will see bare die. One novel thing that we've noticed is that people are starting to handle ultra thin bare die. You'll see SMT, but traditionally you will see finer and finer SMT components, passive devices, being inductors, resistors, capacitors. You will see some plated through-hole technology, but it's really for being able to do the high power types of applications. In terms of mechanics, you'll see a variety of enclosures being used. You will see micromotors, servos, micropumps. And so now you begin seeing the variety of electromechanical, optomechanical. You start seeing really appreciating the fact that these systems can be very complex. We've also noticed in terms of substrates, no longer is it simply um, organic or inorganic. You're starting to see glass, you're starting to see silicon, you're starting to see FR4, BT. Also, these organic and inorganic options, you're starting to notice that people are thinking of using traditional processes for rigid substrates, but we now are starting to see flexible and stretchable and 2D and 3D conformal systems. So again, a very big change in terms of how we handle the substrates onto which we put some of the components that were mentioned previously. And then ultimately the materials themselves. I can remember a day when you had two types of materials, uh, adhesives, one adhesive that worked and one adhesive that didn't work. Now I think that you'll find that open up any catalog or go to any website or any conference, you'll notice that people are introducing truly functional materials. These are specially designed materials that now provide very specific electrical performance, very well controlled in terms of minimizing drift as you go through temperature excursions. You're also noticing a premium placed on the ability to dissipate thermal properties. Optical grade materials are also very important as you start building out a significant amount of plumbing that's necessary for optical communications or optical transfer of data. And then mechanical, we still need these materials to be able to provide that mechanical integrity because these systems are no longer just sitting on your desk, but they're going into different areas of performance, whether it's underwater, whether it's high temperature on the surface of the Earth, or even as we start seeing many more electronic systems being put into low Earth orbit. Next slide, please. So the one thing that I would like to introduce is the term platforms. For those of you that have been observing platforms over the last 30 years, you may remember the desktop. Uh, Computer was a platform. You may remember that when the desktop computer became something more of a laptop. That was a new platform. Some people, with the advent of the smartphone, they consider that a platform. What we'd like to encourage people is to use the term platform when referencing different areas for complex and integrated systems. We have platforms that are definitely very common in the aerospace industry. We have platforms for automotive industry, and now we're starting to see platforms being used as a term as new data centers are coming online. And so when you look at complex integrated systems, it's really important to put it in the context of platforms. And then also when you look at the platform, I think it's important as a community that we are able to identify all the different places that it is possible to think of deploying a design or a material or a system that ultimately does become the foundation of a complex integrated system. And so I'd like to encourage the use of complex integrated systems as well as the term platform as we start looking at all the different end verticals that will be improved with the emergence of these complex integrated systems. Next slide, please. So the one thing that you'll notice is we see a significant amount of blending. I think that blending is the tradition, not traditional, but it's the evolution as companies see opportunities to move along the value chain. Um, as you move along the value chain, to be able to differentiate yourself, you see that you are able to innovate, and your innovation is able to reap benefits because as you innovate, you can achieve higher margins and ultimately differentiate yourself. So we basically see that with the growth of CIS, we're starting to see definitely advancements in terms of how people are viewing the equipment, the materials, the designs used for wafers, components, modules, and systems. We also noticed that with CIS, there's been an uptick in terms of design. We're seeing the term system design being used much more often. We definitely are seeing that term used at many different venues, whether it's a semiconductor venue, whether it's a packaging venue, or whether it's a trade group venue. They're all using the term system design. So no longer is it simply several engineers working on a part of the design, but it's a collaborative effort where people come together and think of the system, the end functionality that system requires. The manufacturing, definitely, there's a significant amount of manufacturing challenges, tools, processes, equipment. I think that some industries, or excuse me, some companies that are moving along the value chain and introducing the capabilities are definitely well prepared for that because they've seen this. They've been starting to be requested for reasons of supply chain resilience to minimize disruption. In those cases, you are seeing companies that have the internal assets in terms of people, equipment, and facilities to do complex integrated system assembly very easily. Other places are not as well prepared. However, I think with this community, as we've seen in the past, as we strengthen the foundation of complex integrated systems, as we start developing process guidelines, as we start developing design guidelines and standards, I think it will be able to help enable companies to join. And then the accelerated growth. There are no boundaries really to growth. I think that everybody realizes that today we live in this environment where there's a significant amount of acceleration. People are always challenging. Product release cycles are getting shorter. Those product release cycles being compressed demands people to do more growth. And so we're going to be on this for quite some time to see this accelerated. Next slide. So before I hand it off to my colleague, this is really, we've noticed this, I've spoken to this. This is the blending. This is the traditional way that we have always viewed the electronics manufacturing ecosystem. We start from going from left to right. Obviously, the people on the left-hand side are the ones that truly have the ability to unlimited opportunity to design features in chips, to be able to think of where we need to be in terms of performance. But the folks on the right-hand side are the ones that actually turn those designs into physical entities. And so, although on the left-hand side, we're going to see an influx of unbelievable designs, and we're going to see individuals presenting a substantive amount of out-of-the-box thinking and innovations and novelty, it really depends on the right-hand side. And so the right-hand side are the representatives from these levels, whether it's the foundry level, the semiconductor assembly, packaging, test level, or the electronics assembly, the third level. And so with that, I'd like to hand it off to my colleague Girish, who's going to go into specific applications. But hopefully I've been able to give you kind of a foundation of CIS. And now please enjoy the presentation from Girish, who will highlight some applications.
Thanks, Dan. I think we all heard a very exciting introduction about the topic from Dan. While Dan, Mark, and I are fortunate enough to present the content to all of you, there are quite a few folks that have contributed to the white paper. The content I am about to present on the applications stands on kind of the shoulders of these experts from the industry, right? So I want to make sure we acknowledge folks from iNEMI such as Sekhar, Francis, Grace, and Linda, Chris and Matt from IPC, Satish from Intel, Rosa from JBill, Mark De Silva from SEMI, as the contributors to the white papers. The white paper is also supported by companies like Acrometrics, AT&S, Integrated Microelectronics, McDermott Alpha Electronic Solutions, MakerSite, Resonac, SMTA, and Zestron. So the content comes curated from several different lenses, and we are just fortunate enough to be able to present this to you. Mark, next slide, please. So as we look at these different applications, I would like to kick it off with an application around massive wireless broadband, particularly based on 5G millimeter wave systems, right? So we all are experiencing this high demand for streaming high definition video. A lot of us are playing online games and we desire minimal latency. We want to experience immersive AR VR content, and that requires data rates at several gigabits per second. We just don't want this exciting content, but we also want it anywhere and anytime, which means increasingly devices have to operate untethered or wirelessly in order for consumers to get the experience they want. Simultaneously, there is a rapid growth in autonomous systems, whether it's for transportation or material movement inside smart manufacturing factories. These systems also operate untethered, and they require technologies such as 5G millimeter wave systems so that it can satiate their demands for the bandwidth, for the high capacity. And it happens to be one of the most promising technology to meet these demands. Now, the high frequencies used in these systems do present challenges for RF front-end design. It also requires significantly increased power consumption. You potentially may have losses in between these components, and then increasingly these systems require complex antenna designs. So that drives in some cases sizes or in some cases duplication of these systems, right? So the need for small cell infrastructure and these millimeter wave bands requires highly integrated RF front ends that can achieve and deliver these ultra high GB capacities. At the same time, shorter wavelengths require smaller structures for signal manipulation, such as filtering, and then antenna designs drive component miniaturization. So in order to achieve these, different system level approaches are being taken. Yes, external antennas are used, but at the same time, advanced RF systems use antenna close to the package, such as the one that is commonly used in a PCB. And you can see from the illustration here on the left-hand side. As that complexity matures, designers are looking at antennas that are now placed on the package itself, right? And then those are suitable for certain applications versus not. And then there is an increasing interest in terms of having the package, having the antenna directly on the chip, particularly with perhaps the chiplet heterogeneous integration approaches. Such antenna systems co-located along with other chips could be a reality or is already a reality. So you can see that in order for us to overcome these challenges, you would require a system in a package or a system on a chip integration techniques. These require innovative antenna designs, and that requires the integration of electronics, mechanical, and software into a into a single complex system. Next slide, please, Mark. So high performance computing is a common topic that is talked very regularly. Here, both edge devices as well as data centers are increasingly relying on high performance computing for tasks such as machine learning, AI, data analysis, and visualization. These machine learning models require massive computational power in order to train and execute. If you have edge devices, and you can really consider an autonomous vehicle as an edge device, a smartphone as an edge device, as well as an IoT sensor as an edge device, right? So these edge devices, regardless of their scale and complexity, need to process data locally. They need to process it in real time, while remotely data centers handle large scale workloads for cloud computing and AI application. Um, One of the ways these are being addressed is through a design approach called chiplets. These are smaller specialized computing modules. These offer more flexible and efficient approaches to building these high performance systems, especially when now you have to think of power constrained environments. So one of the ways that these opportunities can be tapped is by minimizing the physical distance. That is the interconnect between different functional blocks, and this has given rise to the electronics modules, the mechanicals modules, and the photonics modules to be integrated as a common system using approaches such as co-packaged optics, on-chip sensing, or even microfluidic cooling or immersion cooling right next to the electronic and photonic system. So as you can see, these systems are integrated in a very complex design, and they are not looked at in isolation, but as a system in place in order for them to figure out the different paths of solutions. Next slide, Mark, please. The next piece in the consumer electronics size that could potentially have a significant impact in the near term would be AR, VR, and MR devices. Now, these systems, by the very nature, require miniaturized cameras. They require miniaturized projectors, displays, and sensors. And this is what really creates a compact, immersive experience, right? In this particular cases, wafer level packaging really enables the integration of these multiple components or subsystems into a single substrate or a system. This allows designers and manufacturers to reduce overall size and weight of the devices. And this is really essential in achieving that more comfortable and immersive user experience. Now, this would require these complex system to be integrated in such a way that top-down assembly processes are required. This will require stacking of multiple components onto substrates using techniques like wafer-to-wafer bonding, flip chip packaging, precision auto alignment between the mechanical optical components like lenses and electronic or photonic optical components like imaging systems or imagers with novel materials, which is critical to ensure that the electronics, the optomechanical components are correctly positioned and corrected. Additionally, all these high precision automatic equipment for both electronics, photonics, and mechanics will have to be kind of co-located in order to ensure high throughput, in order to ensure single digit precision, micron precision, and repeatability. So this kind of goes back to the last slide that Dan showed, which showed that the different processes, the different manufacturing equipment that were used in these multiple different levels of a complex integrated system are being increasingly co-located, are being increasingly connected to each other in terms of handing over the assembly processes and so on and so forth, right? So that requires not only just integration of the design or the system you are building, but also integration of the manufacturing manufacturing flow, integration of the equipment and the facility, and so on and so forth. Mark, next slide, please. Um, Advanced driver assistance systems are clearly becoming very common. The passenger vehicle camera sensor subsystem market alone globally is projected to be close to $12 billion by 2030. Now, all this is really driven by integration of subsystems and similar subsystems then are integrated for autonomous vehicles that are used for material movement, autonomous vehicles that are used for, say, example, drones, and so on and so forth, right? So they rely on various sensors like cameras, radar, and these subsystems, right? They typically use exterior cameras, interior cameras, LiDAR, which provide some critical functionalities like 360 surround view, blind spot cross traffic alert, and so on and so forth. Now, manufacturing of these systems, right, requires advanced technologies because you need precision placement, you need material control. The entire system has to be ruggedized to ensure reliability and performance in the demanding environment. And by the way, it is really at a single place where all these different subsystems are being brought together. Whether it's the electronics, whether it's the optics, whether it's the radar technologies or the mechanics, all of these come together. So these subsystem manufacturing processes in high yield volumes requires addressing challenges such as sub 5 micron precision placement, controlled micro volume metering and dispensing of material, packaging of materials that enables operations in aggressive environments, but at the same time making sure these different systems, electronics, mechanics, and photonics, they all kind of work together in controlled processing parameters. Again, this kind of a complex system requires not only the design to be looked at it from an integration aspect, but also the manufacturing, like Dan pointed out, has to be addressed upfront in order to make sure the handover from processes to processes happens seamlessly. Mark, next slide, please. All right. So all this brings us to one of the last applications, which is integrated photonics, right? Now, the demand for highly integrated photonics is driven by the need for high-speed communications and high-performance computing hardware. And you kind of saw that theme throughout the applications I talked about, right? Whether it was in the form of imaging or whether it's in the form of photonics for optical communication, this merging of mechanical, optical, and photonic structures, electronic integrated circuits and optical structures, and the pure mechanicals. This is happening everywhere, and we saw that in almost all the applications we just talked about. All these all these systems would have to be connected both wirelessly, and then they have to be connected through a tethered connection in order to move this data quickly, efficiently, and at high without any latency and at high resiliency, right? So for that, you may see fiber optics or hardware is already evolving from being pluggable transceivers to onboard optics to co-packaged optics, and then finally optical I/O. Now these will enable optical engine and ASICs to be physically placed close together. It will also require us to integrate fibers, connectors, shields at the package level. This will drive improving signal integrity, increasing bandwidth, and then reducing the interconnect electrical path, as well as the energy consumption per bit transferred. Now, the complex integrated system toolbox, both from a design, materials, and a manufacturing perspective, provides a comprehensive set, right? So this toolbox can be used to address the various challenges in this product design and manufacturing. Metrology and test is a critical element and a critical piece of this entire toolbox, right? We have to make sure you have less losses. We have to make sure if optical waveguides are produced, then they have to minimize optical losses. different components such as couplers that are crucial for efficient light transmission have to be integrated, and we have to basically ensure high efficiency modulation of these light signals to achieve the high bandwidths that are desired. So a complex integrated system manufacturing site, as the one Dan pointed out on one of his slides earlier, can offer several of these critical capabilities, and it will require the entire ecosystem to work collaboratively together. The collaboration within the ecosystem and with the ecosystem is one of the keys that has emerged out of some of the recent events, such as the Semicon event in Taiwan and in India, right? So all these different applications will have this common complex integrated system platform, and the toolbox, both from a design, materials, and a manufacturing perspective, can be leveraged in order to build these different applications that will help us that bring some efficiency and kind of hasten the time to market to deliver these complex systems. With that, I would like to hand it over back to Dan for our call to action.
Thank you, Girish. Next slide, please. So did everybody read items that are in bold? I think that as a community, we tend to feel that each of us has a role and a responsibility, and we definitely see that role and responsibility starts with technology and innovation. And so what I'd like to suggest here is really it's more of a methodology that we start introducing guidelines, standards, best practices to encourage us to have a foundation for growth. And so a significant amount of work obviously has happened over the last few years with the digital transformation. And so I encourage everybody that use that information that has been stored and don't use it as a repository, but use it as a innovation accelerator. Be able to make sure that you adopt design tools. We're seeing that the bridge or the chasm between the virtual and the physical world is quickly disappearing. And so we encourage people to make sure that you use whatever appropriate design tools are out there. We encourage individuals looking at the talent pipeline to make sure that those tools and the practices that we use are being used by students in academia. And so that's very important, because I think that those design tools are going to be par for the course going forward. The other one is the investment. We've seen that typically based on where you play in those different verticals, the investments are multiples, several orders of magnitude different between a foundry, a semiconductor packaging site, and a printed circuit board assembly. Yes, the investments are high. Those investments typically are the barriers to entry. But what we've noticed is that there's a significant premium placed on the information, the knowledge, the individuals. And so the barrier to entry of having those individuals, having that knowledge has gone down. And so now really the only barrier is one of equipment, access, and facility. And so we think that going forward, it's appropriate for all of us to continue to share when appropriate, and then also make sure that we encourage our supply chain to look at improvements. And so part of the road mapping activities, part of the conversation should be around what we as a community think are necessary going forward, and to make sure that we have the appropriate equipment functionality listed in some of the roadmaps. Next slide. We will, in this group, continue to do a significant amount of situation awareness. We are collecting this information. We're going to many different venues to try to ensure that we are not missing indicators. So situation awareness is definitely of great importance. I mentioned guidelines and standards. We encourage you to discuss potential new work projects around standards and guidelines. As we said, IPC assisted. We have individuals from SEMI that were reviewers of the white paper, like Mark Da Silva. We definitely will be asking them what their stakeholders see in terms of the next series of guidelines and frameworks. Obviously, data exchange formats is a big one. We definitely see that everybody wants to be able to sit at their desk and be able to go from modeling their product to watching the model of the manufacturing line, and then ultimately watch a virtual representation of the product in the field. That's only going to happen when we as a community agree to what are the different formats, what is the type of information that is being exchanged, the data, and then also the ability to share the data and have some type of exchange. The assembly techniques, we definitely feel that there is going to be a significant amount of focus on sustainability. So it is going to be important that we look at novel ways, novel materials that will allow us to recycle the materials and extract some of the materials that we don't want to be distributed within our ecosystems. And so then the last thing is really, we encourage people to join. We encourage people to promote this activity, and within your organizations or within your network, please report out this CIS. And if you have any questions, please reach out to iNEMI, Mark, myself, or Girish. Next slide. And so if one is really looking at all of the different activities that are going on between CHIPS Act, between innovation, between learning opportunities, and just the general virtual to physical ideation and industrialization of products, you ultimately can see that CIS is really one of the core elements that's driving the future. And so as we look at what's next is not too far away. We started out by talking about packaging and how we've been monitoring the packaging trend over the last few years. Well, here's an example of some of the types of elements or systems that people are discussing. You heard the word chiplets mentioned several times by Girish. People are starting to move away from simply a monolithic piece of silicon, but instead going to chiplets, which each individual chiplet is dedicated to a specific function, thereby requiring or using the feature sizes on that wafer as appropriate, and then having now the ability to integrate all of that on a complex substrate. We also are starting to see that people are leveraging things such as embedded die technology, embedded passives. They're starting to look at novel ways of designing antennas. All of this is really this rich environment that we've been stressing over the last 50 minutes. It's here, it's appropriate, and the folks on the call, it's up to us to be able to drive the familiarity of CIS, as well as all the different tenets required to be successful. So with that, and leaving you with what the future is, I believe the last slide, Mark, is yours.
Yeah, so thanks for your attention, everybody. Up on the screen is a link to the white paper, which I also put in the Q&A and in the chat. This also has our contact information for Girish, for Dan, and myself. I wanted to ask if you do have any questions, please use the raised hand function or type them in. I've seen one question come in through the Q&A so far, but I also wanted to launch a poll that we had, which hopefully is working, about what would you like to see us do next in terms of complex integrated systems. So hopefully the team system has sent that to you, and if you fill that out while we're going along, that would be great. But if you do have questions, please let me know those. Raise your hand or otherwise type into the chat window. The Q&A that I saw, so I think this is to Dan and to Girish, is with CIS, known good die seems even more important with the investment in value in the assembled system. Has this been addressed for all these different types of chiplets and subsystems?
That is an awesome question, and I have heard people ask that question, but I have not seen a proliferation or growth of responses. I think that's a very important question and one that needs to be identified. Known good die, especially in these systems, is critical because some of these systems you cannot rework them. And so I think that's very important, and perhaps that's a topic that should be considered for focus in one of these groups. Thank you.
And I think this is where a systems level design approach would help, right? Because if we want to enjoy the benefits of all these systems being brought together into a common platform, right? Then I think the answering the known good die in order to keep the yield high and the costs low, but also at the same time looking at the design and designing in some for example resiliency in the design itself in order to maybe accommodate any variation that you may see will become critical.
There is an ask in the chat window from Ray about, could a series of 2 or 3 hour webinars be done on each of the different elements of CIS, even at a charge for those webinars? So obviously iNEMI could arrange those kind of things as long as we have as long as we have folks that are willing to speak and present, and those are typically free for our members. But I don't know what Girish, Dan, does some of that already exist perhaps, or do you think that would be a good use of people's resources and times?
Oh, definitely.
So is that to just present what the challenges are? Or is that to really try to figure out the solutions? Just thinking that the time of 2 to 3 hours would be like pretty in depth. So we would need speakers for that.
Yeah. Hey, Ray, I'm gonna unmute you if that's okay, and you can ask you can maybe elaborate a bit on your question if you're okay, or your thoughts. You should have control of your mic now, Ray, if you're still around. Might not be. Yeah. Okay. So not getting additional feedback. So folks, if you're able to answer the poll question, which was really about what do you want us to do next? So Ray typed his in chat. That's great. I will capture that. You're not able to unmute. Okay, understood, Ray. Sorry. Don't know that I can do more. Yeah, unfortunately, yeah, I can't. Okay. If you have anything to elaborate on, I guess you will have to type that into the chat window. I'm sorry. I have limited controls.
Mm-hmm. So I think there is a plan for different elements coming up of CIS, and we don't have those nailed down yet, right? But yeah, so in-depth tutorials, I think that would be great. And to what kind of level of maturity do we have here? Are there people already doing this, or is this like we have so many gaps that we need to develop some of those things? Does anybody know?
Thanks, Mike.
Yeah, I think I can. This is Ray
There's
here.
Ray. Hi, Ray. There you are.
Oh, okay, so I can, yeah. Yeah, I think, you know, obviously the main thing would be that people who are able to speak on each one of those, there are a lot of moving parts in there, like one of your slides shows all those, each element of that CIS. So you'll need the people who know those subjects in depth. So it's, you know, it could be quite a few, like, yeah, this is an example. So you need people who are willing and able and have the materials to do those in-depth tutorials. And whether it falls into the charter of iNEMI or not. And the members, iNEMI members, you know, obviously would be free, but anybody else would be charged for those things. And just a way to sort of, you know, what you are saying is all good, but you also need to teach everybody about each one of those things, and you need the expertise of the people who know these subjects, you know. And obviously, maybe you can't do all of it, but you can pick up key pieces from in this box that's on this slide, you know.
So Ray, do you know some people that are experts on these things?
I mean, well, some of these elements I don't, because there's a lot of expertise needed, right? So,
Yeah.
Yeah, from each one of these. So there are certain things people in this room can speak to some of these things, but there are a lot of other things that, you know, you need a different. So no, to answer your question, no, I obviously it was one person. I don't know whether he can in depth cover all of this. Probably that's
certainly
possible.
not. Yeah, that's why these could be very helpful to inform everybody all of it. So
yeah, a group of 4 or 5 people could do it. You know, 5, 6 people.
No, that's good feedback.
Something to think about.
Yeah, well, we're trying to figure out how to make this series valuable to everybody.
Yeah,
so
because this is very high level, very good overview, right? Just define the big things. That's excellent, and people can go and explore in their areas, but also be aware of the whole picture. So this is a good, excellent seminar that you had to give you the complete picture. So that's very nice, you know. But most of us who are in the industry, we kind of know this, you know, but to go into in-depth some of these will be very nice. And especially from the people from those platforms like automotive or aerospace and other areas that are working on that, because you have a new definition of what platform is. You know.
Right.
Something to think about, you know.
Yep. Nope.
I agree. Thank you, Ray.
Thank you.
All right.
All right. Anything from anybody else? I know we're a few minutes past time, but I have some technical difficulties getting us started, so my apologies.
Yeah. Excellent presentation.
Sure, Ben. I'll send a note.
Excellent.
Ben.
Thank you, Ray.
All right. Anything from anybody else before we sign off? And if you want to hear this again, we will be running this back this evening. There is a second session. If you're interested, or if you have colleagues that were not able to join today, please feel free to pass along that we're going to have an evening session as well.
There was a comment that Poly didn't work, and
I saw, yeah.
Yeah, I had the same problem. I had to sign in, and then it didn't like that. Yeah.
Okay. Well, we were trying something new, and it didn't work as well as we hoped. So yes,
I was able to get a response in, but then it was still asking for me to log in to my organization, and anyway.
Yeah. All it was, Ben, was to say, what would you like us to do next? And do you want to speak? Yes or no? And give me your contact information if you're interested. That's what it was. But I will send that out as a note for everybody. We're just trying to gather what do you want us to really work on next? And that was what I think the conversation that Ray gave us, and others. So thank you very much to our speakers. Thank you so much for your time, and be on the lookout for the slides and the recording here within the next week or so, once we finish up everything and clean up the recording. So thank you so much, and everybody have a great day.